Hello friends, this is Chandrakant Ghosh. In my previous video, I have already talked about process capability. In this video, I'll talk about normal capability analysis. Capability analysis is to determine whether the process is producing output that meets the customer's requirement or not. Before going for capability analysis, there are few things you have to keep in your mind. These are: first one is, to perform this analysis, you must specify USL and LSL to define your process requirement. LSL and USL is nothing but your customer's requirement. Second one is, for this analysis, data which you are collecting should be continuous. If you have attribute data such as count of defects or defectives, then use binomial or Poisson capability analysis. Third one is, data should follow a normal distribution. That means data which you have collected should follow a normal distribution. If data are not normally distributed, then capability estimates will not be accurate for your process. If your data is not normal, then you can transform them by using Box-Cox or Johnson's transformation. And if transformation is not effective, then consider using non-normal capability analysis. To determine whether your data is normal or not normal, you have to do the normality test, which I'll talk about later in this video. Another point is, the process must be stable and in control. If the process is not stable, then the capability indices may not be reliably used to assess the capability of the process. And the last one is, you have to collect at least 100 data points, that is 25 samples of subgroup size 4 or more. Otherwise, over a long period of time, data may not represent the different sources of process variation. Now let's take an example of normal capability analysis. A call center in charge wants to assess whether the call handling time of an inbound process is meeting customer's requirement or not. Customer has given target, which is 17 minutes, LSL which is 40 minutes, and USL which is 20 minutes. That means no call should drop before 14 minutes and no call should go beyond 20 minutes. And the average call handling time is 17 minutes. He asked team leader to collect data and do the analysis. So the team leader has taken 5 samples in every hour. In this way, he has taken 100 data points. Here are 100 data points, which you can see, 100 data points. So the team leader has taken 100 data points from the process. Now, first of all, you have to check whether your data is continuous or not. Data is continuous because time, height, length, these all are continuous data. Now the second point is, you have to check whether your data is normally distributed or not. For that, you have to conduct the normality test. For that, you have to copy your data and paste into one of the column of Minitab software. And after that, you have to perform these steps so that you can get this chart. So after pasting your data in the Minitab software, you have to follow these steps. That is, you have to go to Stat tab, and then you have to go to Basic Statistics, then you have to select Normality Test. Once you have selected Normality Test, you will see that the average handling time will be displayed in the left side of the window. You have to double click on average handling time, and then you will see that the average handling time will be displayed in the variable space. On the title space, you can write any name for your graph, like I have written here normality test for AST. Similarly, you can write any other name also. After that, click on OK. You will get this graph. And in this graph, we have to check the p-value, because if the p-value is greater than or equal to 0.05, then the data is normal, or if the p-value is less than 0.05, then your data is non-normal. Here you can see the p-value is 0.260, which is greater than 0.05. That means your data is normal. Now you need to check whether your process is stable or not, because for performing capability analysis, your process must be stable. So you'll check your process is stable or not. For that, you can use any continuous chart like IMR chart, X bar R chart, or X bar S chart. Here I have taken X bar and S chart. Again, you have to follow these steps to get this chart from the Minitab software. You have to go to stat tab, and then you have to go to control chart, then you have to go to variable charts for subgroup, and you have to select X bar and S. Once you have selected X bar and S, a new window will open where you have to click on the blank space in the right side of the window. After that, you have to double click on average handling time. You will see that the average handling time will be displayed in the blank space. And after that, you have to click on OK. You will get this graph. In this graph, you can see that all the data points are within the upper control limit and the lower control limit. That means the process is stable and in control. Once your process is stable, then you can perform the capability analysis. Again, for capability analysis, you have to follow these steps which I have written over here. You have to go to stat tab, you have to go to quality tools, you have to go to capability analysis, and then you have to select the normal. Once you have selected normal, you will see that the average handling time will be displayed in the left side of the window. You have to double click on average handling time. You will see that the average handling time will be displayed on the single column space. After that, you have to enter 5, because you have taken 5 samples as a subgroup. That means your subgroup size is 5, and you have to enter 14 because LSL is 14. Then you have to enter 20 in upper specs, and then you have to click on option where a new window will open, and you have to enter in target. You have to enter 17 in target, and then you have to click on OK, and then again you have to click on OK. You will get this graph. Now in this graph, you can see that the target is 17 and sample mean is 17.21. That means there is a centering issue in this process. Now if you see in performance, ppm total under expected within, there are 3,05,603 calls which are not meeting customers requirement. And in the graph also you can see that there are many calls which are going below the LSL, and there are many calls which are going above the USL. That means there are 3,05,603 calls which are not meeting customers requirement. And now if you see the CPK value, which is 0.32, which is less than 1.33, that means the process is not meeting customers requirement. There are variability in the process, and there is centering issue in the process. Therefore, the process in charge will have to improve the process by reducing variability and centering the process target. So this was all about normal capability analysis. I hope you like this video. If you like this video, then don't forget to subscribe it by click on the bell icon. Add your valuable comments and share this video to your friends and colleagues to improve and refresh their knowledge. We'll see you in my next video with another topic. Till then, have a good day.